Okay, guys, so let's get started without any further ado. In today's class, we'll be going with the first topic called networking fundamentals. This is going to be our prerequisite for the cybersecurity course. Again, a very important concept, understanding what IP addresses are and what are some important networking protocols, what are the categories of IP addresses, okay, and again, how this is helpful in cybersecurity also. Okay, so okay, let's get started. Now, again, if this is your first class, please note we have taken up a demo yesterday. I've covered what the course is about, what is certified ethical hacking, and what is cybersecurity, and what tools we'll be working on, what concepts we'll be learning. So we have covered all that yesterday. Okay, and again, if you haven't accessed that session yet, you can get it available on YouTube. You just have to search for cybersecurity DURGASOFT and access that first session's recording. Okay, and this is the first class of the actual course where we'll be covering the first prerequisite called networking fundamentals. Okay. Now, when we talk about networking, guys, this is basically the concept of connecting information systems with each other. In an organization, you have all sorts of endpoints. You have your routers, you have your switches, you have your client operating system desktops, you have your servers, you have your IP cameras, printers, whatnot. So the practice of connecting all of these information systems with each other so that they can share resources or data is called as networking. And that collective group of those devices is called as a network. So that interconnected collection of devices which can communicate with each other is a network. And each of those individual devices is called as a host. Okay. As mentioned, the previous set examples, computers, printers, routers, mobile phones, IP cameras, again, your Bluetooth-based devices, smartwatches, etc., etc. All of these devices are basically hosts. Okay. Now, just like how we humans have our names to identify and address each other, these devices also have names, and those names are called as IP addresses, Internet Protocol addresses. Okay. To define it, each host on the network has a unique identifier, and these unique identifiers allow for communication to occur between them. And that identifier is known as an IP address, Internet Protocol address. When these were invented, there were multiple versions of them. There was IP version 1, IP version 2, IP version 3, etc., etc. They didn't work out successfully. What properly worked out was IPv4, Internet Protocol version 4, and we're still using IPv4 addresses even in today's world. Okay. To define an IPv4 address, as mentioned, it is the unique identity given to every information system in a network. And this IPv4 address has some important properties to it. Firstly, your IPv4 address is a 32-bit address. What I mean by 32-bit is that it contains 32 zeros and ones. A bit is the smallest data value a computer can hold. It can either be the value of 0 or equal to the value of 1. And your IPv4 address contains 32 zeros and ones as such. Okay. And this entire 32-bit address again is divided in 4 equal parts, where each part or each portion consists of 8 bits in it. And each of that 8-bit portion is called as an octet, and each octet is separated by a dot symbol. So this is what your typical IPv4 address would look like. So you have 8 bits here, and then another 8 bits here, and then another 8 bits here, and then another 8 bits here. And each of these 8-bit portions is called as an octet, and each octet is separated by a dot symbol. Okay. Now, what we see here, this language of zeros and ones is very commonly known as the binary language. The reason why we call it binary is because it contains only two characters, zeros or ones. Okay. So again, what we humans regularly use in our day-to-day life are the decimal characters, numbers from 0 to 9. So now I'm going to show you how do you convert any binary number to a human readable decimal number. So this number 11000000 is actually equal to 192. This number 10101000 is actually equal to 168. This number 00000000 is actually equal to 0. And this final number 00001010 is actually equal to 10. So how is this conversion happening? How can we convert a binary number to a decimal number is what we'll figure out now. Okay. To convert any binary number to a human readable decimal number, there are two simple steps. Step number one, write down the values of 2 power 0 all the way up to 2 power 7 from right to left under each bit. So the rightmost bit here has 2 power 0. And as you go to the left, you're increasing the value, 2 power 1, 2 power 2, 2 power 3, 2 power 4, 2 power 5, 2 power 6, 2 power 7. So irrespective of what number you have on the top in binary, you just write down these values from right to left. So here we have an octet with the value 10101010, and under that octet here, I've written down these values, okay, from 2 power 0 all the way up to 2 power 7. Now, once these values are written, then you multiply the lower value with the top. 2 power 0 into 0 plus 2 power 1 into 1 plus 2 power 2 into 0 plus 2 power 3 into 1 plus 2 power 4 into 0 plus 2 power 5 into 1 plus 2 power 6 into 0 plus 2 power 7 into 1. So whatever value you have on the top, irrespective of that, you multiply the lower 2 power value with the top bit and you add it till the end. To perform this calculation now, we need to know these values from 2 power 0 all the way up to 2 power 7. So anything to the power 0 is always equal to 1. It's a mathematical rule. So 2 power 0 is also equal to 1. 2 power 1 is 2 itself. 2 power 2 is 2 into 2, that's 4. 2 power 3 is 2 into 2 into 2, 3 times, that's 8. 2 power 4 is 16. 2 power 5 is 32. 2 power 6 is 64. And 2 power 7 is 128. Now that we have these values here, you can multiply them. You can substitute them and start multiplying and adding. 2 power 0 into 0. So 2 power 0 is 1. So 1 into 0, that's simply 0. Plus 2 power 1 into 1. So 2 power 1 is 2. So 2 into 1, that's 2. Plus 2 power 2 into 0, that's 0 again. 2 power 3 into 1, that's 8. 2 power 4 into 0, 0 again. 2 power 5 into 1, 32. 2 power 6 into 0, 0 again. 2 power 7 into 1, 128. Now that we have all these values, we can add this up. So 128 plus 32, that's 160. Yeah, 160. 160 plus 8, 168. 168 plus 2, 170. So when we humans read the number 170 as 170, the computer reads it as 10101010. Something like high frequency, low frequency, high frequency, low frequency, high, low, high, low. When that exact series of frequencies goes to a computer, the computer understands it as the number 170. Okay. So now the reason I'm explaining you all this conversion from binary to decimal is so that we can get the entire range of IP addresses. So if I have to get the first IP, all I have to do is put zeros everywhere. In the first octet, all zeros. In the second octet, all zeros. In the third octet, all zeros. And in the fourth octet as well, all zeros. So when you put all zeros everywhere, the final decimal value for the first IP is 0.0.0.0. And if I have to get the last IP, how do I do that? I put all ones everywhere. So when I put all ones, I get the number 255 for that. If I just go one slide back, when I put all ones, okay, you just have 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1. And with that calculation, we get the number 255. So the last IP you would have is 255.255.255.255. Here's the first IP and here's the last IP. We got this entire range from the concept of converting binary numbers into human readable decimal numbers. Okay. And if you have to calculate how many IPs are there in total, each bit here has two possibilities, zeros or ones. Okay. So you have to multiply that 32 times. So 2 power 0, sorry, each bit is 2. Each bit has two possibilities here, as mentioned, and there are 32 bits. So the total number of IPs you would have is 2 to the power of 32, because 2 into 2 into 2 into 2, 32 times, because there are two possibilities in every bit of the 32 values here. Okay. So 2 to the power of 32 would give you the number 4.3 billion IP addresses. So when these were invented in the 1950s or so, they thought 4.3 billion is a very large number. But fast forward to 2025, the population itself is close to 9 billion people. And each person, again, has multiple devices at home, right? So 4.3 billion IPs assigned to each system would never have sufficed. So that is why these IPs are again categorized in different types. Okay, so there's something called as classes, class A, B, C, D, and E. And there's something called as public and private IPs. So each class has, again, two sets again. Class A has public and private, class B has public and private. Class C also has public and private. Class D and Class E are exceptions. They don't have any private IPs in them. all of them are public IPs itself. Okay. But before we learn what these public and private IPs are, let me talk about the sequencing of IPs. Okay. How are the IPs progressing one after the other? We know what the first IP is, we know what the last IP is. We have to learn the sequence now in between. Okay. That's a very simple logic here to understand the sequence as well. But before that, before we get into the sequencing part, any questions or doubts up to this point? Renuka or Srinivas? Okay, assuming no questions. Right. So to understand the sequence again, there are two simple rules here. So for rule number one, you always start incrementing from the rightmost octet. What I mean by incrementing from the rightmost octet is you increase the value of the rightmost octet by one. So if we have the first value of IP as 0000, next IP would be 0001. Next IP 0002. So if you notice, the rightmost octet is increasing by one. 1, 0, 2, 0, 3, 0, 4, 0, 5, 0, 6 goes all the way up to 0, 2, 5, 5. Now, once the rightmost octet reaches the maximum value, then you reset it back to the first value again, which is 0, and then the left octet increments by 1. That's rule number 2. So once the rightmost octet reaches a maximum value, only then you move to the left octet. And the rightmost octet should reset back to the first number. Okay, so after 0, 2, 5, 5, you have 1, 0. Now after 1, 0, don't directly jump to 2, 0. That would be wrong. Remember rule number 1, always increment from the rightmost octet. So after 1, 0, you have 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, which goes up to 1, 2, 5, 5. And then you have 2, 0. Then 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, which goes up to 2, 2, 5, 5. Then 3, 0, 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, which goes up to 3, 2, 5, 5. Like that, the pattern keeps on repeating. And somewhere down the line, you would have 2, 5, 5, 0, 2, 5, 5, 1, 2, 5, 5, 2, 2, 5, 5, 3, which goes all the way up to 2, 5, 5, 2, 5, 5. So now the rightmost two octets are full. Once these two octets are full, they cycle back to zeros again, and the left octet increments by 1. So you have 1, 0, 0 after that. Okay. Now same logic, same pattern. Whatever repeated from 0, 0, 0 to 0, 2, 5, 5, 2, 5, 5. Same thing repeats from 1, 0, 0 to 1, 2, 5, 5, 2, 5, 5. Okay. So 0, 0 to 0, 2, 5, 5, 1, 0 to 1, 2, 5, 5, 2, 0 to 2, 2, 5, 5, 3, 0 to 3, 2, 5, 5. Same pattern. Whatever repeated here. 0, 0 to 0, 2, 5, 5, 1, 0 to 1, 2, 5, 5. Same pattern repeats here. Okay. Then after that 1, 2, 5, 5, 0 goes to 1, 2, 5, 5, 2, 5, 5. Then you have 2, 0, 0. Okay. So 2, 0, 0 goes up to 2, 2, 5, 5, 2, 5, 5. 3, 0, 0 goes to 3, 2, 5, 5, 2, 5, 5. 4, 0, 0 goes to 4, 2, 5, 5, 2, 5, 5. 5, 0, 0 goes to 5, 2, 5, 5, 2, 5, 5. And down the line, you would have 2, 5, 5, 0, 0 going up to 2, 5, 5, 2, 5, 5, 2, 5, 5. Once all these three octets are full, the last octet increments by 1. So whatever cycle repeated from 0, 0, 0, 0 to 0, 2, 5, 5, 2, 5, 5, 2, 5, 5. Same cycle repeats from 1, 0, 0, 0 to 1, 2, 5, 5, 2, 5, 5, 2, 5, 5. Then from 2, 0, 0, 0 to 2, 2, 5, 5, 2, 5, 5, 2, 5, 5. 3, 0, 0, 0 to 3, 2, 5, 5, 2, 5, 5, 2, 5, 5. 4, 0, 0, 0 to 4, 2, 5, 5, 2, 5, 5, 2, 5, 5. Like that, the pattern keeps on repeating. And somewhere down the line, you would have 2, 5, 5, 0, 0, 0. 255, 255, 255, 255. That's the last IP. So if you count each and every single IP there, you would have a total of 4.3 billion IP addresses. Okay. And again, as mentioned, all of these 4.3 billion IPs are divided in various categories, which are your classes and public and private IPs. So in today's class, let's talk about what public and private IPs are. In the next session, we'll cover what the classes are as well. Okay. So talking about public and private IPs to understand these in the simplest way possible, let's take the example of our home network. Now, in our home network, we have multiple devices. We have our Wi-Fi router, we have, let's say, a laptop, a smartwatch, a smartphone, a smart TV, whatnot. All of these are our local intranet devices, your local private network devices, okay, or your local area network devices. Now, any of these devices, when they want to communicate with each other, they need something called private IPs. So private IPs are the IP addresses assigned to each individual system in a local area network. Okay. So in your private network, when the devices have to communicate with each other, they use private IPs for that. Now, when any of these devices wants to communicate with the internet, for that it needs a public IP. So your router gets a cable from outside the house. Okay, that cable is again basically an optical fiber cable or an RJ45 cable, and that is provided by the ISP, Internet Service Provider. Right? So when you take a new internet connection, the ISP guy comes and sets up a router, and to that router, a cable comes from outside the house and connects to your router in the backside. Right. So that cable is what carries the public IP. And this public IP is what you need for connecting to the internet. So when any of these devices want to communicate with the internet, they'll access it through the router, which is getting this public IP. Okay. So if my laptop wants to communicate with google.com, first it sends the packet from the laptop to the router using the private IPs. Okay. And then the router shifts the packet from the private network to the public network. That's the job of a router, to transmit data between two different networks. Okay. And then with the public IP, it reaches the internet and accesses the various websites on the internet. Okay. So if you have to check what your public IP is, you just have to go to your browser and oh, 1 second. Yeah. So you have to go to your browser, and in your browser, you just have to do a search. What is my IP? You can click on any of these websites as well, and that would show your exact public IP. So this is the IP being provided to my Wi-Fi router from the ISP, Internet Service Provider, broadband internet. This is Act 5 minute. Okay. And if I have to check what my private IP is in the Windows command prompt, so you can open up your CMD command prompt in Windows, and here you can type ipconfig. That shows the private IP as well. Okay, so this is how you check a private IP, and this is how you check the public IP. This is the IP which I'm using to connect with the internet. So to connect to any website on the internet, I need a public IP like this. This can only be provided by the ISP. To connect with any other device in my local network, from my laptop to another laptop, or from my laptop to my phone in my same Wi-Fi network, I need the private IP for that. With these private IPs, I can communicate in the intranet in the local area network. Okay. So that is what a public IP is, and that is what a private IP is. And coming to the classes again, so these are the 5 classes as mentioned. And each of these classes has its own unique ranges. Class A starts at the first IP 0000. Class E goes up to the last IP 255, 255, 255, 255. This is the entire range of classes, guys. And we're going to talk about what these classes are in the next session. Okay. Since these are demos, I'm going to keep the sessions a bit short because I'm not sure who else is going to join and who has missed out the demos earlier. So today's session is a bit short because this is the first demo of the actual course. Okay. This is the first class from the course. And again, I don't want all the others to miss out much more content. So if you have any queries also, if you have any questions also, we can clarify those today, guys. And one more thing, if you have missed out the earlier session, you can go to YouTube, and here you can do a quick search. You can just search for cybersecurity DURGASOFT, and you can filter it out by the latest or recently uploaded recording. And this is the demo which I took yesterday. So if time permits, you can go through this recording as well. I've clearly explained what topics we'll be covering. Again, what tools we'll be working on as well in the last session. And this was a seminar which I took. Okay, not this one, sorry. That's the older one. Yeah, this is one of the seminars. You can access these also. Okay, so anything. So you can at least access this one to access the last recording, which explains in detail what topics we'll be covering in the course in the upcoming sessions. Okay. Yeah. If you have any questions also, you can let me know now, guys. Srinivas or Renuka, any questions regarding cybersecurity or regarding the course. So don't worry, only today's session is a bit short because as mentioned, I'm still waiting for the others to join the upcoming sessions. So tomorrow we'll take a slightly longer one to complete the networking fundamentals. Yeah, Renuka, you're saying. Renuka, your voice is getting muffled. I can't hear you properly. Please repeat.
Okay, when will the regular class will start?
Is it only
Hello.
my
audible?
Uh,
Uh,
I, some issue with the mic, Renuka. Your wife, sorry. The voice is getting muffled in between here and there, yeah, and it's getting cut. I think it's a Wi-Fi issue or something.
Hello, Shoaib.
Yeah, Srinivas. Do you hear the same way or is it just me?
Yes, it's same for me.
Right.
Yeah. Is my
Okay.
voice audible
Your
correctly?
voice is properly audible, actually. I don't know
Uh,
what the
just
issue
want
is.
to have one suggestion. Actually, I'm working as a Java developer with 4+ years of experience.
When will the regular
Um,
class start? Okay. Yeah. Srinivas, please go
yes,
ahead.
actually, I need one suggestion. Like, how can my project myself with for the new when I have taken up this course, when I'm trying to apply for the cyber security roles or for these jobs, how can
Right.
I project
So if you're
myself like
planning on
yes,
transforming your career into a
yes,
cybersecurity related domain career, then this could be helpful, Srinivas. You can start applying for penetration tester job roles. Okay. Or if you're towards, again, if you have knowledge on JavaScript, you can again translate that towards web application security as well. Okay. But again, this deals with mostly network pen testing, understanding what networking devices you have in an endpoint, and on those devices, how do you rectify vulnerabilities? So again, as a Java developer, this is completely different because you're not going to learn how to
yes,
test the security of any application as such. We'll be learning how to test the security of endpoints or network devices and the vulnerabilities that commonly exist on them. What misconfigurations exist on these devices, or if any applications have a known vulnerability on them, how do you verify, how do you perform exploitation, and how do you remediate them? So completely a different domain from development, I would say, and transgressing into cybersecurity or penetration testing, Srinivas. So you could either use your existing experience as writing it as secure code testing. You can convert that and try to apply for application security testing. But this doesn't cover application security. This is more about network security.
actually,
Srinivas.
I'm trying to come out of this coding role. So
Then this is the perfect one because, again, as mentioned, this cybersecurity thing has little to no amount of coding at all in this domain, and especially in this course. If you're going towards network security, there's requirement of no coding at all. You just need to learn what tools are used in cybersecurity, tools like Nessus, Metasploit Framework, Burp Suite, etc., and it shows you basically how to again learn the security testing of endpoints and applications on them.
okay, mainly these courses focus on network security rather than the application security.
Right, exactly. And yes.
So just can I have a brief on difference between big? Is this covered in yesterday's session?
Yeah, actually, we covered that in this session
Okay,
yesterday. What tools will be
then I
working?
will go through that video before
Sure,
tomorrow's demo. If I have any more doubts, I can ask tomorrow.
definitely, definitely. And yeah,
Thank
we'll be providing the recordings as well, Renuka. So yeah, you'll have the online sessions and every session is recorded and you'll be getting the recordings on your Google Drive. The duration of the course is 35 days, where we have classes from Monday to Friday for 1 hour each. These are demos, so the sessions are shorter, but once we have registered students from the regular classes from Monday, it's going to be a 1 hour session. Okay. 45 minutes of session and 15 minutes of doubt clarification in the end. Right. For any further queries, again, I think most of your queries would get clarified once you go through the recording, Srinivas. But if you do further have any, we'll connect back tomorrow and clarify those as well.
Okay, sir. Okay, thank you.
Sure. Renuka, any questions on your record decision? Where should for you, as mentioned, all once you've registered, they'll be available on your Google Drive in the shared with me folder in your Google Drive account. Right. So yeah, that's that. Nothing further, guys. We can exit the session here. We'll connect back tomorrow at the same time. We'll take a
Okay,
much
sure.
longer one tomorrow, guys.
Okay, sure.
Thank you, guys. Bye bye. Good day.